record this. I feel like that's how all my videos start. And let's start the recording. It always mentions the recording. I don't know, it's just how it is. Okay, so, so boring down here. I'm sitting. I want to be standing, but it's hard to write standing up. So anyways, I think you'll find that my handwriting is bad enough. So, all right. So the first question, kind of starting off easy, you had a few of these kind of solve for X situations. As we go through these, what I'm going to do is I'm going to show you guys where to find extra work problems, right? So more of these problems. So if you're finding that, oh man, question 2 is really hard, I need more practice on that. Sometimes the hardest thing about asking for help, especially with math, but really any subject, is knowing what you need help with, right? It's like, oh, that chapter was really hard, but you don't really have a word for it. So what I want to do is just kind of give you terminology for each of these types of questions that we've done, right? And then you can kind of sit down and work more on those problems that, that you have trouble with. Okay? Now, where's that little thing where I wrote down what they all were? Okay. So I don't know if you noticed, but on Moodle's kind of a work in progress. I've got to prepare sections. So for each week, I'll kind of tell you what to do to prepare if you need to study for a test, for example. That's kind of a given. But things like bring a calculator, especially today, usually every day, but just things like that, read chapter 2 or whatever I need you to do. For this week, we're just going to remember that math is 80% attitude, okay? So we're going to do it. It's going to be great, okay? And so depending on how long we take today, we'll do the skills assessment. We might keep working on it on Thursday. I don't know. 2 hours is a long time, so yeah. But up top here, I posted the Learning Center practice problems and solutions. Okay, and so there's a link, and so if I hit that, it'll take you to the Learning Center where Kate has been kind enough to prepare all these practice problems with solutions for you to work through. Okay, and so I'll tell you what each of the questions that we're doing, which kind of section it's from. You'll notice that there's multiples of exponents and solve for X, but they're usually the same. There's only one. I think exponents, there's 2 versions. So anyways, both are good though. But yeah, so lots of different topics. Of course, we can kind of ignore the chemistry and the physics sections, except for the scientific notation and unit conversions. Those got slotted in there. Okay? But so just, if you're not feeling confident with the math, because, well, let's get real, I saw your skills assessments. So, no. I actually think that they were really good, okay? Because I've taught the wet students in stats typically, and that's like way later in your schooling. And you guys are about on par with the skills, so that should feel really good. The hope is though to bring you a little bit higher, right? So let's go back. Oh, let's go back to here to Moodle. I also wanted to let you know that I found a 4th edition of the textbook that matches the course outline magically. And so I just updated that yesterday. And so if you were looking at it before, I'm sure nothing's changed, and I'm sure you weren't. So there's that. But if you were looking at it, I did update that, that PDF just yesterday. Okay? But that's the one we'll be using. Okay? All right. So, solve for X, huh? All right. So, question 1 is kind of from 2 different places. For A and for B, I'm just gonna write here on the side. I want more room though. Kind of move it over. How about? So for A and for B, these are from the section just called Solve for X. In fact, you'll find these questions in there if you look hard enough, right? But then you kind of know what's what. Okay, so this one, just kind of starting off nice and slow, right? And so solving for X, just getting comfortable with moving things around in an equation, right? So to move things from one side of an equal sign to the other side, right? We basically have to do the opposite, right? And so we want to get X on its own. So we're trying to shake out the X. And so what I like to do, I just hold the X steady. So the 13X in this case. And then I know that I have to move everything else around. Okay? And so I want to move the 7 over to the left-hand side. And so to do that, I have to add 7 to both sides technically, but I'll just show it on one. And even if you don't want to show every single step, that's fine. I do want you to show work though. So whenever you're doing something that's, you know, kind of drastically changing, then you should write it down and let me know, right? I'll show you what I mean for a harder question. How about? So we're going to do 84, oh, right on the line. 84 plus 7 is 13x. I meant to, oh, what the? It's not on there. My pen's up here. I don't know. Okay. Hey. It's a pop quiz. If I'd had more room, I would have tried to align the equal signs. So these are things that just from math, right, is really kind of important to me. I understand what you're doing if you're not aligning your equal signs, but in general, I try to align equal signs. Here, that text was way smaller than I write, but from now on, I'm going to try to keep my equal signs aligned, okay? And that's something that easy for everyone to do. You can just keep in mind, that's not even math. Keep your equal signs aligned, okay? There are a few cases where I don't, but anyways. 84 plus 7, I have a cheat sheet, it's 91. One thing that you should know about me, I guess, is I don't do math in my head. I don't, I'm not ashamed of it. I have a math degree, so what? It's because we don't really do math. By the end of my math degree, I was doing like 1 + 1 on my calculator, just to be sure, right? And so I was kind of ruined that way. People always think that you're going to be really good at like head math. You're not after a math degree. Anyways. All right, 91 is 13x. We want to get the x alone, so 13 is multiplying the x, and so to undo it, so to speak, we have to divide both sides by 13, right? And so 19, oops, there we go. And by 19, I mean 91. 91 divided by 13 is 7. Here's where I do a switcheroo. Another math thing. At the end, or as soon as I can typically, I like to put the x on the left-hand side. So here, this is like a swing door, right? It doesn't matter which side of the equal sign you're on, right? And so it's, you can just as well write x on the left-hand side. And I just will always do that. Just kind of swing it around as soon as I can. As soon as I have x on its own, I'll just put it on the left and it'll be one foul swoop. Or is it fell swoop? It's not English. Fell, right? But I always say foul because it makes me think of a bird. All right. Excellent. x is 7. Congratulations. All right. How about B? Copy. Nope. Nice and big. Okay. Stepping up a little bit because we have to collect like terms, but nothing crazy here, right? So we want to get x's on one side and everything that's not x on the other side, right? And so I like to survey the scene because I don't like dealing with negatives. And actually, once I was looking at this calculator, because I was just getting familiar, I had a hard time finding the negative sign, but it's on here. I'll show you when we need it. So what am I gonna do? Well, I don't want to deal with a negative x. So what I'm gonna do is I'm gonna move the 6x over to the right-hand side and move the 5 over to the left-hand side, right? And I'm gonna do that in one shebang. Okay. So I'm gonna have -8 minus 5 is 7x minus 6x. Right? Just kind of untangling the mess. Okay. Of course, there's steps in between there that you could be showing, but nah. We have to stop within reason, okay? So then we've got -8 minus 5, and this is where I had to figure out where the negative was on here, and it took me a little bit too long on this calculator, this new end angle calculator. It's this button here, so I guess 4th from the top. It's got brackets with a negative sign around it. So if you hit that and then 8, you get -8 minus 5 is -13. And then 7x minus 6x, that's nice to deal with. We're already at x, right? So sometimes you want to survey the scene a little bit and see what's going to make your life easier, right? As long as you follow kind of math rules, doesn't matter which way you do it, but some ways are easier than others. Okay? And so I'm going to write my answer is x is -13. You could have stopped earlier because they're saying the same thing. So if you're struggling with those, that's fine, but you will need to put in some work, right? Because those are pretty core concepts, okay? But you can look at the Solve for X questions on the Learning Center website, okay? And Kate is really good at this type of material, right? And so for this whole course, she'll be a really good resource if you're too scared to come to me, but you're always welcome to come see me. Okay. Any questions about that one before we go to C? Can we go faster? Absolutely not. This is all I have prepared for today. No. Actually, it is. That's not a lie. But I don't think that we're gonna run out of material. All right. So this one, I'd say the first 2 questions were fine, right? And so everyone's probably feeling okay. This one, things kind of derailed a little bit. Saw some good ideas on there. But the key thing here is to remember that when you're moving things around, right, you've got 5 over x plus 4. To move x plus 4 around, you have to keep it together, right? And so you have to move that as one thing. And so there's a couple of ways that you can do it. For me, as soon as I have kind of a fraction on each side, I like to move this guy over here and this guy over here, and then I don't have any fractions anymore, right? And so that's nice. And so technically what we're doing is we're multiplying on both sides, right? But it ends up looking like 5 times x minus 2 is 3 times x plus 4, right? Keeping in mind that it's important to now put brackets around the x plus 4 and the x minus 2 because they have to stick together, right? They have to be treated as one thing. So now we can start breaking out these brackets, right? We can multiply the 5 inside, but it has to multiply on both x and negative 2, right? So to ditch the brackets, we've got 5x minus 5 times 2, which is 10, is equal to 3x plus 3 times 4, 12. Now we're back here, right? We're back to the problem we were just solving, right? Where we've got x's on both sides and just the number on both sides, and we have to collect like terms and slowly solve for x, right? And so just doing a quick survey here, I don't want to have to deal with a negative x, so my initial thing would be to move the 3x over to the left-hand side. But then as a bonus, I get to move negative 10x over to the right-hand side, and it's positive, so I don't have to deal with any negatives. I don't know about you guys, maybe you guys love negatives, but I think it's pretty common to not like negatives. They've got some weird behaviors sometimes, in inequalities, for example. So we've got 5x minus 3x is 12 plus 10. I just look at the 5x minus 3x, and I know I can just do 5 minus 3 is 2x, right? Technically, I'm pulling out a common x, right? And then I'm dealing with the numbers, and then I'm multiplying them back out. You don't have to do that, right? But if you're kind of wondering why it's happening, that's why it is, because we're pulling out that common x. So we've got 2x on this side. 12 plus 10 is 22. And so x is 22 divided by 2, so x is 11. Can I get a what? No what's? Come on. Yeah, that's fair. That's fair, actually. Shouldn't even be asking. Any questions about those few? Oh. Chugging along. Okay. All right. Moving on to question 2 then. Oh, you know what? I forgot to tell you guys. Well, maybe I should, it's been a whole summer, so I forgot I have fancy colors in here. That last one we just did is in the rational expressions sheet. For question 2, at least A and B are from the bed mass and FOIL worksheets, right? Are those concepts? So bed mass, remember, is just the order of operations, so the rules of math, right? And so we're brackets, we have to deal with brackets first, and then exponents, and then division or multiplication, they're on the same playing field, right? So then you just do them in the order that they appear. And then addition, subtraction, again, are on the same playing field. and you do them in the order as they appear. Okay? So for this one, we're just gonna simplify these, right? Boil it down to as little as we can. Okay? So brackets, first step, right? We've got big brackets, so we've got square brackets, we've got round brackets, so we have to go deepest inside the brackets, right? Deal with those first. So we've got x plus y inside our brackets, multiplied by 6. And what I saw a lot, and Kate was kind of like, hey, why are people doing this? I think you guys were just in a hurry, and what you saw was x plus 6 in brackets, right? But you have to be very careful. I know it was a stressful event on that skills assessment, right? So I completely understand. And I actually appreciate that than going the other way where you ignore brackets, right? Making up brackets is, well, maybe it's not that great, but it's better than ignoring brackets. Okay? So what I was seeing a lot was people kind of treating it like this, right? Which it isn't, right? But I think that's the simplest explanation to you and the most common mistake that happened here. Okay? So what we have to do is, well, BEDMAS says that we have to go inside our brackets. Inside our brackets, we have to look for more brackets. We found some, right? Inside these brackets, though, we don't have any exponents, so that's great. There's no division or multiplication. There's addition, but we can't do anything with x plus y, so we have to move outside our brackets, right? Because then we've done what we can inside those second brackets, right? So now we move outside those brackets, and now we've got multiplication, so 6 times x plus y. So we're gonna kind of mow down those brackets first. So we've got 3 on the outside, just hanging tight. X is just gonna hang out 2. Plus, and then 6 times x plus 6 times y, right? We have to bring that 6 inside both things. Terms, I guess they're called. 6x plus 6y. And square bracket.
So are you only multiplying the far left x if it's in brackets as well?
That's right. Yeah. Yeah, so that's when you would do the oil. Yeah.
So just to like think about it as like 2 terms inside the square brackets, like if you color coded them, the x would be blue as 1 term, and then like 6 bracket x plus y.
Totally.
Another color as another term.
Yeah.
Just to like wrap your head around.
So here's one guy, here's another guy. So you mean?
Yeah.
Yeah,
okay.
Totally. I'm going to erase that though, but yes. So now these guys are all willing to play ball, right? We've got x plus 6x plus 6y, so we've only got addition in here, right? And so we can combine the x and the 6x. So now we have, whoops. Oh, green's nice too, but I prefer blue. Three times. So x plus 6x is 7x. 6y we can't do anything with, right? There are no other y's. Y. So we're stuck. Okay? But that's all right. So now all that's left to do is to bring that 3 inside, right? So it's just hanging out all the way outside until the very end. 3 times 7 is 21x, plus 3 times 6 is 18y. Oops. And I ditched the brackets because we don't need them anymore. They're not doing anything. Although I guess if you wanted to, you could do that. But you don't need to.
just did normal. I didn't combine like terms and brackets first.
Oh, that's fine. Yeah. That's just me being lazy because I only want to multiply the, what is it, the 6?
You want to do this 7 instead of this X.
Yeah. So, but that's just me being lazy. Right. All right. Are we ready for B or what? Doesn't really matter. We're doing it anyways. I'm all tough nurse on you. All right. It's a biggie. There's a lot of brackets, right? And so what you're gonna do is just hope that one of these brackets can kind of go away, right? And so it looks promising. Right, we've got -7 outside the big brackets. We know we have to carry them forward, but we just ignore them until the very end, right? And what's nice is first thing I look at is inside these brackets, right? 4 plus 1, I can just make that one number, right? So it's not as bad as it looks, right? Same with 7 minus 2, you can just collapse that into one number. So it's really just 5 times 5 there. Right? So not as bad, right? Here we will have to do some work, right? With the x plus 2 and the 4x plus 3. But inside each of these brackets, besides making this 5 and 5, there's no more simplifying that I can do, right? And so now I have to go outside these brackets. So here we go. So we've got -7 hanging out. And then what I'm going to do is I'm going to do 5 times 5. I'm just going to show that. You don't have to if you went straight to 25, that's fine. But just in case someone's looking back at these, like, where'd the 25 come from? Surprise. Okay. So now we've got x plus 2 times 4x plus 3, right? We know we have to FOIL these, I guess it's called. So what I'm going to do, so I don't have to deal with this negative, is I'm just going to put my work inside. So I'm going to make some more brackets here. Right. And so then I can just ignore that negative because you have to remember to pull that negative in onto each term, right? And so it's better to just leave it until you've simplified it a bit so you don't forget any. All right, so we've got, FOIL's pretty fun, hey? Just kind of cascade through, right? So we've got x times 4x is 4x squared. Do you guys remember what it looks like? It's like this, like this, like this, and like this. All right. So we've got 4x squared, right? X times x is x squared. And then we've got x times 3 is 3x, and they're positive, so we can just add them. Then we've got 2 times 4x, both positive, so we have 8x. And then 2 times 3 plus 6. All right. Keep the -7 out there. I know it's going to be tempting, and this is more of a note for later on. If you have something big that you're just carrying through, I know it's tempting to just drop it, but don't, right? Put in that work and just write it out every time. Hey, it's free work, right? You don't have to do anything for it. Just write it down, right? And so now it's just -7, so it doesn't hurt, right? But if you've got a huge fraction that you're carrying through all the way to the end, right? Like I said, it's tempting to drop it, but don't. Okay? So we can deal with the 5 times 5 on its own, right? We can just write that as 25, be done with it. Okay. What I'm gonna do is I'm just gonna collect like terms inside this, for this polynomial, right? This is a polynomial. So because I've got 3x and 8x that I can combine, right? It doesn't matter. It's just less work later on. Okay. So I'm just gonna do 25 minus, and then 4x squared, 3x plus 8x, 11x, and then plus 6. Making sure to keep those brackets on, right? Because we haven't brought that negative inside quite yet. So we've got -7 times 25. Now I'm going to bring that negative inside so I can ditch those brackets. So I've got -4x squared minus 11x minus 6. Same idea, I'm always on the lookout for things that I can collapse, things that I can just kind of collect like terms. I've got x squared and I've got x, there's nothing to do there, but I've got the 25 and the minus 6 that I can kind of bring together. And so I've got -7, and I guess that makes 19. Minus 4x squared minus 11x. So now there's nothing else I can do inside the brackets, right? So now I can bring this -7 in, just making sure that you pay attention to the negative, right? -7. So this becomes 7, so -7 times 19 is -133. -7 times -4x squared is plus 28x squared. And -7 times -11x is plus 77x. That's the end of it. But like I said, anything that kind of looks like this, where you have x squared and x and then a number, right, or even x to the power of 3, 4, 5, anything like that is called a polynomial, right? And so for me, another math hang up is I like to write them in descending powers, right? So I just want to rearrange it so it looks like 28x squared plus 77x minus 133. Yeah.
How do we know to stop there and not just bring something over the other side and keep going?
Can't stop, won't stop. Because it's not an equality, right? So because you don't have an equal sign here, there's really nothing that you can do. You could solve for the zeros, for example, but
So I definitely couldn't add 133 to both sides.
No, because there's nothing wrong with those.
yeah, because all I'm saying, so this equal sign here is actually just me saying this is equal to that.
Okay. Yeah,
Right.
So it's not actually.
Yeah, so we don't know what, it's not equal to anything.
Jesus, right.
Yeah.
So that equals kind of isn't there.
Yeah.
Like when I was solving it on my own, I did something that was wrong, but might be helpful to know like why it was wrong. Is I thought I could like take the square root of 4x squared to combine it with the other terms, like it would be like 2x. But obviously, you can only do that when it's an equality. I guess.
That's right. Yeah.
Because you're not going to do the other side.
Yeah, because yeah, so it only applies in an equality, and it would only apply if you're doing it to both sides, right? And so, good idea though. But yeah. So yeah, I guess it's a fake equal sign. It's equal to the first thing, but it's not an equality. Just some terminology. When there is no equal sign, it's an expression, right? And when there is an equal sign, it's an equation. Not that it matters. It's just, yeah. Write it big on top of your notes. This is an expression, not an equation. No, but it is good to know because there's a difference. Okay? But yeah, so that one was a biggie. And I think as long as you're kind of being careful, paying attention to brackets and negatives and things, then you'll be safe. Right? Any questions about that first page? No? All right. How about did you guys get a chance to finish the second page, or want some little bit of time? How about a little bit of time? How about 6 minutes? Because it's 8:44. I guess I could pause the recording for 6 minutes. Start it back up again. So part C of question 2 is from exponents. There's actually 2 versions of it on there. One has the rules of exponents, right? So if we're on the worksheets here, right, I think there's exponents in the pre-calculus section, right? So here, this is the one I was using, but then there's also exponents, and it just looks like this. Just a ton of practice. Fun. Mad minute style. You'd have to caffeinate first, though. So you've got exponents there. And then there's also exponents for the business math proficiency test. It's all good math, right? So if you look in there, it actually has the basic exponent rules as well. So there's even more practice. So, but I was using the one in the pre-calc section. Not that it matters, but it's nice because here we've got a little review of the basic exponent rules. I wonder if I can steal this. Sure. Only because I want to steal this. That's good to have. I guess I'm a bit of an information hoarder. Right? So here, it's from the exponents worksheet. I use there's 2 versions, right? This is essentially pre-calc, so you can use the pre-calc ones. But like I said, the business math one has these handy rules. And so I don't doubt that you'll have to use exponents in your work. And so it doesn't hurt to go through these rules just kind of briefly, right? Just as a fact, anything to the power of 0 is just 1, right? That's weird, but it is. Anything to the power of 1 is just itself, right? So here we've got a base A, and then later on we've got a base A and B, right? and just how they behave. So this is usually how I'll present math rules, is with variables like this. But if you've got the same base A, right, one with a power of n and one with a power of m, to combine those, right, to just one base, yeah, that's not right.
We should be adding them, right?
Yeah, you should be adding them. You're simply going to multiply? No. Yikes. Okay, I'll have to like, okay, no. This is not right. N plus m. Making me second guess my whole spiel here, but no. This one's right. I think it was a simple copy paste error. A to the power of n to the power of m, these powers are being multiplied, right? So there's not two bases, right? So that's when you can multiply them together. Yeah. Same thing here. If you've got a times b inside to the power of n, then you can break it out and say, well, that's the same as a to the power of n times b to the power of n. And conveniently, if you have a to the power of n over a to the power of m, then what do you do to combine these bases? You subtract the exponents. What's your shortcut for nth root? This is kind of off track, but it's good to know. Good to know. Hey, don't teach me stuff I don't need. Well, you'll need it, so. What if you have the nth root of a? Just as a fact. So then you can actually, to calculate that, it's a to the power of n, or 1 over n, right? And so that's how you would find the 31st root, for example, which we were joking about up here. Okay. We don't have any nth roots on here, so don't worry, but that's how we're gonna do it. Right? All right. So for these little guys, no biggie, right? We've got these brackets. They don't really mean anything because we're multiplying all the way through, right? Multiplying, 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 multiplying. And so they don't really do anything. So we've got, what I'm gonna do is I'm just gonna write them next to each other to start, right? Collect my bases of x and collect my bases of y. They're still just multiplying, so I'm allowed to move them around however I want, right? Multiplication's nice that way because we can do whatever we want. Well, sort of. So just rearranging things here, ditching those brackets because they're not doing anything. Okay. So now I've got this situation here, right? Where I've got the same base, x, and then y, right? Yeah.
Oh, why are the two brackets considered like two terms? Like, is it not like x to the power of 3 times y to the power or times y to the power of 6? Like, so you wouldn't like, because my instinct is like 4 or whatever.
Totally. And so, and that's good, but it really only matters if there's addition or subtraction in there.
Okay.
Right? And so that's when you have to keep track of, okay, I have to expand this thing, right? But here, because, so you would take the x squared, and yeah, you are multiplying it by the x to the 8, right? Yeah. But that's what I'm doing here, right? So it's a little less intense than the FOIL. And so I've just kind of rearranged these. And like I said, this is just because we're multiplying, right, that this is allowed. And so we've got this situation here where you've got a to the power of n times a to the power of m. And so to combine these to just one base, then you add those powers. Okay. So we've got x to the power of 2 plus 8 then y to the power of 6 plus 4. So from here, right, I can do 2 plus 8. Even I can do 2 plus 8. No, I will. I can do anything, but there's only a few things I will do. You can quote me on it. So, and then y to the power of 10. Right. There's actually, so if you left it here, I would be perfectly happy with that. That's fine, right? But what's nice is that we have the same power, and so we can actually collapse them if we want to. So we can rewrite this as xy all to the power of 10, if you wanted to. That step's kind of optional, right? Just using this rule here. Any questions about that one? Okay. So let's do the next one then. So we've got a little bit more here. One thing that we should make note of is that 1 over a in general to the power of n, right? So essentially, if you have something to the power of n in the denominator, then you can rewrite that as just a to the negative n, right? And that just shows that it used to be in the denominator. For fractions, I don't know about you guys, but I had a heck of a time remembering which one's the numerator and which one's the denominator. The top one's the numerator, bottom one's the denominator. And the only way it stuck was the numerator's numero uno, so it goes on top. And the denominator, well, it's on the bottom. It's not the numerator. It got demoted. Yeah. No, denoted. No. I was just trying to make it work with the words, but it doesn't really work. Anyways, so however you remember that, you've got a numerator over a denominator. Here's like kind of good to know notes on the side, I guess. Well, equals a fraction in case it's been a long summer. Okay. So, all right, so here we've got a fraction, right? What I like to do when I'm kind of simplifying exponents is I like to use this fact and just bring everything in the denominator up to the same playing field as the numerator. So how do we do that? It's just by negating those powers, and then we can bring them up. Okay? So we can do this and say x to the 7 times y to the 8. Okay. These guys are just going to multiply, right? Because they're dividing, so to kind of move them up, you're just multiplying. And so you've got x to the negative 9 times, oops, sorry, y. Y to the negative 4. Uh-oh. No, negative is good. It's really good. Okay. So we've got 2 bases of x, 2 bases of y. I'm going to do the same thing that I did earlier and just collect those so they're sitting next to each other, right? The x's and the y's kind of sitting together. Again, because I'm multiplying, I can do that, right? They can move freely. So we've got x to the 7 times x to the negative 9, y to the 8. Should I keep the negative negative 4? No. You got it. Just 4. Okay. So now I can see these and kind of group these. And so what do I have? I have x to the power of 7 plus negative 9. And y to the power of 8 plus 4. So I have x to the power of negative 2 and y to the power of 12. Bless you. You can definitely leave it here. Oh, question? No? Yeah?
Okay, so I put x to the power 2 and y to the power negative 12.
Ooh.
So I moved the bottom over. So on the opposite, I just graded in equals and moved it over. So it's like over 1.
But again, because you don't have that equal sign, we don't know what it's equal to, right? And so
how do you get that? Then how do you just move the
so here, what I did was, okay, well, I can rewrite this. Okay, so here's a little side note. If I just were to rewrite this, x to the power of 7, y to the power of 8, x to the power of 9, y to the negative 4. What I can do is I can say, I just told you can't introduce equal signs, but as long as you're keeping things equal, you can, okay? And so what I mean by that is you can say, well, that's the same as x to the power of 7, y to the power of 8 times 1 over x to the power of 9, y to the negative 4. That's still true, right? So you can't introduce an equal sign and say this is equal to 4 or something, or even 0. 0 is kind of our go-to, right? But we can't do that. Or in your case, I think you were just using 1.
Oh, yeah, I was just
you were
using 1 over 1
multiplying.
and then multiplying.
Totally. But we can't do that. What we can do is we can say, okay, well, I'm going to manipulate this, right? Still keeping it the same equation, but just rewriting it in a way that I like, right? So now I can rewrite this. I can shift them over, right? Because technically, if you care about that kind of stuff, that top half is over 1, and the other half is under 1, I guess, and then we're multiplying here, right? So as long as we're doing that, we're doing the same thing, right? So these two things are equal, right? We want to rewrite this, right? We can do it piecewise if we want. For example, keeping the equality, we've got x to the power of 7, y to the power of 8 times 1 over x to the 9 times 1 over y to the negative 4. That's still true because we're multiplying, right? One big no-no would be if we're adding down here and we split these up, that's not the same thing. Right? But because we're multiplying, it's safe. Okay? So now, right, and this is why I showed you this trick, and I know it's hard to look at these kind of variables and translate it to your problem, right? But here we've got 1 over x to the power of 9, right? 1 over x to the power of 9, which I can rewrite as x to the power of negative 9. And then same thing here, 1 over y to the negative 4, I can rewrite as y to the negative 4. Right? So I guess I skipped a few steps. X to the 7, y to the 8. So here, now I'm just times x to the negative 9 times y to the negative 4. And that's how I got those. Right. But once you go through and you do a few of these practice problems, right, I think you'll end up doing the same thing that I did in the beginning, where you just say, oh, I want everything on top. Just shift it up, right? And so you're basically just making these powers negative to move them up top into the numerator. Like I said, here, at x to the power of negative 2, y to the power of 12, you're done, right? That's fine. But if you want to take it a little step further, that's the same as y to the power of 12 over x to the power of 2, right? Doing the same thing, but in reverse, right? Where now I have a negative power, which I know just bumps it down to the bottom, right? X to the power of 2. Making sure that you drop that negative, because 1 over x to the negative 2 is just x squared. Thanks. Just got to be careful. For complete, I'll just finish this for completeness sake. 7 minus 9, y to the 8 plus 4. Got sloppy, but there it is. Okay. Any questions about that one? What question are we on? D. Enjoying notability. Come on. That was that one. This one's similar to the one that was on the, so for a lot of these, I've added some questions that weren't on the skills assessment just to kind of bolster our work here. Because it was hard to just keep it to the skills assessment, right? But this one was on there. I think it was pretty good for most people, right? Where you're just, okay, the square root, I think it was just x squared on your skills assessment. Right? I think it was the square root of x squared over the square root of 36. Perfect squares. Perfect squares. But if you want some practice here, before I forget, it's in the worksheet called Radical Expression Practice. And that's for E and F. I'll just stick an equal sign on here, right? The square root of x to the 4th, there's not much we can do here, right? It's just x squared. Why is it x squared though? But why though? Because if you rewrite, right, and this is why I showed you here, the square root is just an n of 2, right? And usually we don't even write it in the little hook, right? So the second root of a, we can rewrite as a to the power of 1 over 2. And so what happens is that we have x to the power of 4, that's on the inside still. Right? So we can rewrite the square root as everything inside it to the power of 1 over 2. Same thing here. We've got 25 inside to the power of 1 over 2. Because we're in the business of kind of simplifying, and we know that we can take the square root of 25, then I'm not going to collapse those square roots on the outside. So what I'm going to do is I'm actually going to bring this to the power of 1/2 inside. And that's just using this, which rule? This rule, but less fancy. So, So this is the same as x to the power of 4 times 1/2 in the power. Right? 25 to the 1/2, we should just be writing 5, right? Because we know the square root of 25. Oh, another thing about, so the square root of 25, oh, it does show up as 5. It likes to give you exact answers, this little guy here. So if you're using this calculator or even the other engineering one, I think it likes to give you kind of answers with the square root and the fraction. And so those are exact answers, and that's why it likes it. Right? A decimal answer is approximate. Right? But I found how to get the decimal answer after a lot of hunting. There's really only so much you can hunt on here, but it takes me a while. Over top of the equal sign, if you're working on this one, there's a squiggly equals. So instead of hitting equals, you would hit shift equals, and it would give you the decimal answer, if you prefer.
Oh, there's a button above delete that says SE. I think it's
Oh, now you've got 2 options. We'll need it in a little bit here, so that's good. We'll try them both out. Cool. Is everyone okay if I just write 5 here? The square root of 25 is 5. Nice. So we're not adding 4 and 1/2 of the powers because they're being multiplied together, right? There's only one base. And so we've got x to the power of 4 over 2 over 5. Right? And that's how we arrive at the x squared over 5. Right? So that's technically where it comes from. A lot of these things you already know, they're already kind of ingrained, right? And so it doesn't matter how you get there, but
What's the square root again? X over 5.
no, just leave it there. That's good. Because again, that would be introducing a square root kind of that doesn't do anything on the other side. So
You're just assuming the power of 4 is over 1, right?
yeah. Okay. Yeah, totally. Sorry. Well, there's no room, but yes. Yes. Cool. So that one's simple, but it's also a good kind of chance to get down into the nitty-gritty of exponents. Okay. How about this nasty? So here, again, we're relieved because we're multiplying inside these square roots, right? As soon as we're adding or subtracting inside the square roots or inside brackets, we can't just do things willy-nilly. By willy-nilly, I mean we can't just break out the square root onto each thing, right? Because adding and subtracting behaves differently. But because we're multiplying, we can actually rewrite this as 3 times the square root of 12 times the square root of x squared. Right? And so then we're dealing with the square root of 12, but at least the square root of x squared is just x, and we can just forget about that for a little bit. Right? Same thing down here, right? We've got the square root of 18 times the square root of x to the 3, right? We can, that's allowed. We can rewrite those. Okay. So here, because I want to have lots of room to write here, I'm just going to rewrite the question. And as long as I'm doing things that keep the equation kind of equal, right? So as long as I'm not changing anything, then I can move things around, I can rewrite them, right? As long as I'm following the rules. Okay? So one of the rules says that I can rewrite this as 3 times the square root of 12 times the square root of x squared, because I'm multiplying in there. Right? So you can do that for multiplying and dividing, right, but not for adding or subtracting. We'll do the same thing, because what I'm trying to do is I'm trying to shake out these square roots or get as few square roots as I possibly can. And so I'll start here and do 4 times the square root of 18 times the square root of x to the 3. Okay. We can try it, right? The square root of 12, it gives me 2 root 3. That's not great. So how about we just get there kind of manually? What I'm going to do is I'm going to use the trick that, okay, well, I'm just going to kind of factor out 12. The highest that I can do is 3 times 4. I know the square root of 4 is 2, right? So I can rewrite 12 as 3 times 4, right? That's allowed. Same thing for 18. I can rewrite that as 9 times 2. That's allowed. Only because I know these kind of lower end squares, right? I know 4 is a square. I know 9 is a square, right? So I'm just kind of going for those. Okay. And so what we do is we have 3 times the square root of, oops, not 12. We just said 3 times 4. And then I'll just write x, because we just went through and said the square root can be just 1 over 2. X to the 2 over 2 is just x to the 1, so you have x. Okay. Over 4 times 9 times 2. And same idea with x to the power of 3. I know I'm not going to be able to take the square root of x to the power of 3, but I can rewrite x to the power of 3 as x squared times x, right? And at least that gives me an x squared to work with. So that's the same as x squared times x. And I can break these out, so I've got 3 times the square root of 3 times the square root of 4 times x. 4 times the square root of 9 times the square root of 2 times x. Oh, sorry. I'm not doing that yet, am I? Square root of x squared times the square root of x. Of course, I am showing extra steps, right, that you don't necessarily need to show. But again, it's always good to show as much work as you possibly can, right? Because that's where the part marks are. Okay? So as long as you're showing me your logic, your thinking, and I'll talk about it closer to a test, right? But if you have an idea of how to solve a problem, even if you're looking at it and I don't know how to solve this problem, but I think I would start by doing this and this and this, as long as you write that to me, right? Communicating that to me is worth something, right? And so whenever you're kind of working through things, just write it out, talk it out, help me get into your brain a little bit, because it's worth something. So it's the worst when I have this huge page and it's all erased, and then I have to kind of, I'll still read it, I'll still try to figure out what they said, but yeah, it's the worst. Just give me something. All right, so we've got 3, the square root of 3. I know I can't do anything with that. My calculator will tell me so, but you also kind of know, right? And so, but square root of 4, I can rewrite as 2 times x. 4 times the square root of 9 is 3. Square root of 2, I can't do anything with. Square root of x squared, I know is just x, times the square root of x. Oh man. Oh, gross. Oh well. My rain jacket's getting fixed and it's not done till Thursday, so. No, I spend all my time indoors anyways. So here, now, it might be tempting to kind of multiply through, and you totally can. But for me, I like canceling things. I find it really rewarding. And so because I'm multiplying everything up here, because I'm multiplying everything down here, again, it's safe, right? So it's kind of a perfect storm here. I can cancel this 3 with this 3, so I don't have to deal with it. Even this 2 over 4, I can rewrite as just 1 over 2, right? So that turns into a 2. This x I can cancel with this x. And so there's not a whole lot left. And so I'll just use a different color here. But this 3 I can cancel with this 3. This 2 I'm going to cancel with this 4 and rewrite it as 2. And this x is going to cancel with that x. So now all that's left on top is the square root of 3. And then times 2 times the square root of 2, or sorry, divided by 2 times the square root of 2 times the square root of x. Just to make it look nicer, the square root of 2 times the square root of x, I can smush them back together, right? Just like we pulled them apart, we can smush them back together just as easily. And so now we've got the square root of 3 over 2 times the square root of 2x. Nice. So that one's a doozy. Quite a bit. And square roots might be long forgotten, but that's all right. Okay. But like I said, so that's the radical expression practice sheet. Might be good. Let's do question 3. You had one similar to this first part on the skills assessment. This is more of the solve for x. Okay. For both A and B, I think, yeah. Okay. So here we've got y is 3x squared. And so we're going to find x if y is 9. Not too bad. So we're just going to plug in y is 9 and solve for x. And so we've got 9 is 3x squared. Not bad. We want to get x on its own, right? And so the first thing we have to do is, well, there's nothing being added or subtracted to it, so just multiplying. So in order to move the 3 over to the other side, we have to divide. So 9 over 3, oops, is x squared. Oh, man. I usually like the sound of rain, but this is bad. Aren't you glad you're in here doing math? Yeah. Hey, I'm in the C building too, guys. So I'm guessing you're heading to the C building later? Oh, I'm sorry. No, it was agreed that the C building was slightly more run down than the B building. So enjoy, I guess. All right, so we've got this x squared that we have to shake out, right? And so to undo the x squared, technically what you would do is you would take the power of 1/2 on both sides, but that is the square root. right, as we know now. Maybe you knew before, but I'll just write the square root of 3 is the square root of x squared. So the square root of 3, you can try it on your calculator. So the square root of 3, it's just the square root of 3, right? I'll just leave it as that. Again, that's an exact answer, so that's good. Is x. And just because I like my x's on the left, yeah. Oh, yeah, that's good. Plus, minus, but I'm actually not going to do that now. But yes. Yeah.
I have a same.
Yeah. Oh, look at you guys. So good. Okay, well, all right. It is plus minus, but I don't. So if you did plus minus, a plus. But if you didn't, that's fine. It's fine. Right. When it's important, I'll let you know.
And so it can be.
Mm-hmm. But I'll let you know if it's important. For us here, yes, technically it is plus minus, but we'll wait to get into that. Ditch it. All right. How about the next one? So finally, we have an equal sign in here, right? So we have an equation. So the left-hand side is equal to the right-hand side. Now we're allowed to move things around, right? Following math rules, of course, right? And so, but I think the simplest thing to do, because we're solving for x, right, is, well, we've got 15x plus 95 here. There's nothing more that we can do to simplify this, right? And so what I'm going to do is I'm just going to bring the 1 over 5 inside. Remember, though, that everything is times 1 over 5, right? And so, and same thing here. This is simplified, so I'm going to bring the 1 over 6 inside. And so what does that look like? It looks like 15x over 5, right? Technically times 1 over 5, but I'm just going to scoot them on top of each other. 95 over 5 is 42 over 6 minus 36x over 6. What's nice about these is they're all divisible by 5 and then 6 respectively, right? So it's not that bad. So we've got 3x, right? 15 over 5x is 3x plus 95 makes 19. Just double check. It does. Sold. 42 divided by 6 is 7 minus 6x. And now we're back to where we kind of started off at the beginning of the worksheet, right? And so we just had to do a little bit of work to get to that spot, but now we know we have to move our x's to one side, our numbers to the other side, right? Collecting like terms. I'm going to move my 6x over to the left-hand side because I like 3x plus 6x. A little short-sighted, I guess, because I'm going to have 7 minus 19, but that's all right. So now I've got 9x is 7 minus 19, negative 12. So getting x on its own, I've got x is negative 12 divided by 9. Oops. For me, if you just left it as negative 12 over 9, that's fine. But it's also nice because your calculator just tells you it's negative 1 over 3. So that's nice. Yeah, on my calc, I just did negative 12 divided by 9. And then it just, that works, yeah, right. Because, yeah, negative 4 over 3 is also negative 1/3. So like I said, even stopping here, I would have been totally fine with that, right? If you're up to it and simplifying even further, that's great, right? Or I'm just cheating and using the calculator output here. Cool. All right. How about, oh, and if you want approximately equal to, oh, I forgot to try it, or x is approximately equal to, if you want to use the decimal version, then you have to use the squiggly equals. I'll be kind of relaxed on that, but negative 1.33 repeating. Luckily for me, we haven't talked about sig figs yet or anything like that, so just ignore that for a little bit longer. Okay. Oh, I want to try that SD. So negative 12 divided by 9. There it is. Yeah, it does the same thing. Nice.
Okay. Oh, I just messed around with my calculator and I found another trick, I guess. So if you do like the negative 12 divided by 9,
Yeah.
and then it's like a lot of our calculations negative 4 over 3.
Okay.
So then if you do shift and then that SD, then it gives you another version. Then it gives you the negative 1 times 1
Whoa.
over 3. So it gives you like every combination of what it could be.
Crazy.
What was that fun? If you do shift SD, then it'll convert the fraction to another type of fraction.
Oh, crazy. Cool. I want to try on, well, that one's not fancy enough. I don't have the other engineering calculator. Yes. Oh, I think this one. Does this one have the same SD? Does, right? Is it behaving the same way?
You have to go to,
Yeah.
go to setup, just shift setup, and then you get
Okay.
change it to line 2.
Because this is the calculator that's in the bookstore. This is what all the other engineering departments use. Looks similar to me. So
We're supposed to have ones that aren't programmable.
yeah, as long as it's non-programmable, non-graphing, you can have whatever you want, right? They look the same to me, right? So, yeah, more or less. And especially if you're used to a calculator, right? Like if you have a favorite calculator, then that's good, right? Because what I'm finding with this one, all my other ones that I'm used to do the square root of 5, for example, I would do 5 and then hit the square root. Whereas this one wants the square root first. So I'm a little bit like, have to redo basically everything. But that's all right. I'll get used to it. Okay. Should we just end here? I think we'll just finish this off next day. We've got 2 more pages. We're not going to get through it. It's actually later than that, so don't worry. Don't worry, I'm not jipping you with time. But yeah, so definitely take some time at home and work through the last 2 pages and just kind of check out those resources that the Learning Center have posted, right? So the links on Moodle. So if you work through those last 2 pages, we'll go through them together next day. Yeah, let's call it. I'm not gonna check it or anything, so you're all adults. But yeah, well, that's what I'm working under. Anyways, I'll see you guys on Thursday.